What is the cutoff, saturation, and amplification of a transistor? A transistor can operate in three states: cutoff, saturation, and amplification. When the voltage between the base and emitter of the transistor is less than or equal to the B turn-on voltage Y, and the voltage between the collector and emitter is greater than the voltage between B, the transistor is in the cutoff state. The turn-on voltage Y of a general silicon tube is about 0.7 volts. When the transistor is in the cutoff state, the current flowing through the base can be approximated as zero, and there is only a nanoampere level leakage current between CE. The cutoff region on the output curve of the transistor is this section below Y, and the cutoff region on the output curve of the transistor is this block area below ID equal to 0, when the voltage between B is greater than the turn-on voltage Y, and the voltage between C is greater than or equal to the voltage between B, the transistor enters the amplification state. At this time, collector current IC equal beta asterisk IB, IC is almost determined by IB, regardless of the voltage between CE. The transistor exhibits current amplification characteristics. In a signal amplification circuit using a transistor, it is generally allowed to operate in an amplification state. The amplification region on the output curve of the transistor is in this block area. When the voltage between B is greater than turn-on voltage Y and the voltage between CE is less than that between B, the transistor enters saturation state. At this time, collector current IC less than beta asterisk IB, and there is a small voltage difference between CE of a transistor. For tens of milliamperes of collector current, maximum saturation voltage drop between CE is generally at 0.3 volts. However, if collector current is relatively large, maximum saturation voltage drop between CE may reach 1 volt when a transistor saturates. This should be noted. In digital signal control of a transistor as a switch circuit, it allows a transistor to operate in saturation state. When input is high level, transistor saturates and conducts with small voltage difference between CE. At this time, it can be regarded as a conducting switch. When input is low level, transistor cuts off with voltage difference between CE equal to power supply voltage. At this time, it can be regarded as an open switch. Saturation region on output curve of a transistor is this block area.